Alrighty guys, welcome to another episode of Video Notes. We are going to be processing through fibers today. We're going to learn how fibers serve as a form of evidence in forensics, how to identify fibers, the different types of fabrics and textiles that are created by fibers, and overall how to analyze them should we find fibers at a crime scene and want to solve a case. So let's go ahead and get into it. So what are fibers in the first place? Well, fibers are literally everywhere. They're in our clothes, they're in our socks, they're on the carpet, they're in pretty much anything that we touch that's made out of fabric. So everything we interact with can produce small fabrics that stick with us. When it comes to textiles and clothing, what is shed is known as a fiber. So I have fibers here, if you guys can see. There's little, almost looks like lint stuff that you would collect in the dryer. That's all fibers. So wearing clothes means that you'll shed fibers around. Sitting on a couch, you'll pick up some fibers. Walking on a carpet while wearing socks, you're probably transferring fibers between your socks and the carpet. So fibers are everywhere, and fibers are really useful because they're not specific to a single person, but they do tell a story based off of the type of fiber, how many fibers we find, and different forms of analysis that we can conduct after finding fibers at a crime scene. Another thing that's really helpful with fibers is that because we shed them so easily and because they tend to be pretty small, it's often the form of evidence that is unnoticed by criminals who otherwise might try to hide any evidence at the crime scene, right? They'll know to wipe off the fingerprints, they know to mop up the blood, but they don't often look to see if their shirt got rid of any fibers along the way. So fibers can really help make or break a case. So looking at the way that we transfer fibers, it follows the principle of Locard's principle of exchange, which is essentially if I interact with something or someone, we are going to exchange some form of trace evidence. So direct transfer is the exchange between the suspect and the victim directly. So it would be like a fiber from my cardigan would transfer to the suspect, or a suspect's shirt fiber might transfer to me. Secondary transfer is where I might pick up, for example, like dog hair by sitting on my couch, and then while I'm grappling with a victim, I might then transfer that dog hair to them. It's being transferred, so it's being picked up somewhere else and then transferred between the suspect. So another example would be like maybe fiber from the carpet ends up on the clothing of a victim, which was then transferred to the suspect. So direct transfer is directly between something on the suspect to something on the victim, such as clothing, something that the victim or the suspect is actually wearing. Meanwhile, secondary transfer is not necessarily directly related to what the suspect or victim is wearing, more so something they picked up along the way that this happened to stick to them. So when it comes to collecting fibers, quick collection is critical. Because of how easily fibers are shed, we could actually lose a lot of our evidence. Within 24 hours, 95% of all fibers might have fallen from the victim or kind of floated away from the crime scene. Fibers are really common components of dust, and we know dust kind of tends to float around everywhere. Same with fibers. So fibers that are not expected are cataloged as evidence. For example, if you were to find pink fibers on the shirt of a victim found in an otherwise pinkless environment, then that would definitely be evidence. But if that victim were found in a house with pink carpeting from wall to wall, then we probably would expect that pink to be there, so it wouldn't be cataloged as evidence. Now, if that pink carpeting was found on the suspect and that suspect had no pink carpeting anywhere else, well then we might be able to make that connection. And then one fun fact that I just thought was fun, in the past, dead bodies were covered with cotton, but we've actually stepped away from that. Now we do plastic tarps. And the reason for that is because cotton fibers shed pretty easily. And if any cotton fibers shed onto the dead body, well, then that could contaminate other fiber evidence that would be on the victim. So if you're wondering why plastic is used, that's why. So when it comes to analyzing fibers in the forensics laboratory, there are a few key ways to analyze fiber. We want to look at the type, the color, the number of fibers found, where it was found, the textile that the fiber might originate from, multiple fiber transfers, type of crime committed, and the time between the crime and the discovery of the fiber. So going a little bit more in depth into this. So the type, we refer to what is the composition of the fiber, how common or rare is it. For color, we want to look at what type of dye gives the fiber its color. Does the color match the crime scene? Does the dye type match the crime scene? So how well do they match? We want to look at number, so how many fibers were found. And this goes into Locard's principle of exchange. More fibers suggest possible violence or a longer period of contact. So as we know, the more that you interact with somebody, the more evidence that's going to be exchanged between you. You want to know where that fiber was found. How close can you place a suspect to the crime of the scene based off of the location of that fiber? The textile, what was the main textile source, where the fiber came from? Is it from the carpet? Is it from the car? Transfer, is there more than one type of fiber present? Is it just a fiber from a cardigan, or is it a fiber from a cardigan and maybe from my sock and from my carpet? So more sources of fiber also suggest longer contact or possible violence, just like the higher number of fibers as well. For crime, you want to look at what type of crime was committed. Was it a violent crime? Was there a kidnapping involved? Every crime has their own expected pattern of fiber transfer between the victim and the suspect and the crime scene. So knowing the type of crime then can give you some insight as to what kind of evidence you're going to look for and where you're going to look for those fibers. And then, of course, to make sure that they correlate to kind of put your whole story together. And then time. How long ago did the transfer take place? So the evidence value of fiber, as we had just learned, is reduced as more time passes because there's just a higher chance that it could have been either lost or contaminated. So when we are sampling and testing fibers, fiber collection is normally gathered with special vacuums that maybe have some kind of mechanism on the hose in order to collect the sample but not actually suck it up into the bag. Or you might inversely get a brand new bag to use the vacuum so that all of the fibers you get end up in that bag, and then you can filter through it that way. You'll use sticky tape, forceps, just like these little tweezers. All of these different types of equipment will be really useful when trying to collect fibers. And then documentation, you really want to make sure that you're accurate in terms of recording the location of the fibers because, once again, because of the nature of how easy fibers are lost, you have to be very clear, very accurate in order for this evidence to be usable in court. So when you are looking at fibers in the lab, you want to identify the type of fiber and its characteristics, and then you want to match it to a source such as a suspect, the victim, a car, a home. You want to know where that fiber came from. So there's two different ways that you can analyze fibers. If you have one fiber, you probably don't want to use a test that would destroy that fiber because it's the only one you have. So you might use polarizing light microscopy or infrared spectroscopy. These are ways to analyze a fiber but still keep it intact. Now, if you have a large amount of fibers, if you have a pretty large sample, well, you could probably get away with burning a few pieces of that fiber. So you can use a more destructive test, being, like I had just mentioned before, burning something with a flame or dissolving something in a kind of solution or a liquid. Depending on how that reaction occurs can let you know what kind of fiber you have. So let's go ahead and watch this video here. It goes through a burn test of different fibers and explains what you might look for depending on the type of fiber and how it might burn. One thing I enjoyed was that I found a lot more videos regarding fibers and forensics and burn tests in the sewing and knitting part of YouTube than I did in the actual forensic side of YouTube. So that was always fun.
Often when we saw.
So speaking of some of the non-destructive ways would be polarizing light microscopy or spectrometry. So using a light microscope for polarizing light microscopy is really nice because it allows us to use a special filter that could then help us change the specific light wavelengths in order to then better understand the makeup of the fiber. Natural fibers only require an ordinary microscope to view characteristic shapes and markings, so that is one way to right off the bat identify differences between your fibers. And then here I just included a picture of the different light wavelength, starting at the short wavelength is more purple, and then the longer wavelength is more red. So changing those wavelengths actually changes the hue of the visible light spectrum, and then of course there's other spectrums as well. So if we were to try and classify all of these different fibers, we would look at natural fibers versus synthetic fibers. So natural fibers come from animals, plants, and minerals that are mined from the ground. So speaking of animal fibers, there's a variety. So animals provide fibers from 3 sources, either hair, fur, or webbing. All animal fibers are made of a protein called keratin. It's the same thing that our hair is made out of, same as rhino horn. Keratin is a pretty common animal protein. So furs are made by drying an animal's skin with the fur attached. So that would be much different than like the fabric that we're used for wearing, right? Like a fur coat has the leather of the animal's skin with then the fur attached to that. Now, hair fibers are the most popular of animal fibers, the most common being wool from sheep, but this also includes cashmere, angora, alpaca wool, llama wool, so many different forms of hair fibers that can be collected. This hair can be collected via brushing, clipping, or even just waiting for the animal to shed naturally. Another animal fiber is silk. Now, silk is actually collected from the cocoons of the caterpillar Bombyx mori, and these caterpillars make their cocoon, which is then unraveled by hand in order to create a thread. And so basically there's one thread that makes up the entire cocoon, and so you have to stretch it all out, and then you'll pair that thread with other threads in order to have something that is easier to then work with in terms of making fabrics. So because of this nature, because the silk fabrics are so long, they don't shed very easily, which means that you're probably not going to be as likely to find silk fibers at a crime scene as you would other fibers. So here I have just a few pictures of the different sources of animal fibers. Here is a good old sheep, and you can see that wool that would be sheared to be collected. This is an Angora rabbit. This is the source of Angora. You can see that they have been bred for having very fluffy coats in order to be able to harvest that fur. This is a goat. This is where cashmere is made from. There's a specific form of goat that has really, really soft undercoat. We're going to learn more about that in the upcoming video. And then this is the silkworm with the then corresponding moth and the silk cocoon that they make. So we're going to watch 2 videos. One is going to go into how silkworms make silk, and then the other will go into the history of cashmere and why it is as expensive as it is. Alrighty, so that was silk. I find it so incredible to learn about the different ways that we've learned how to use what, at least to me, just walking around, I'd see that and probably not think to make fabric out of it, right? But I don't know, I just love to see how we interact with the natural world. All right, so that was silk, and now let's look at cashmere. Alrighty, I don't think I've ever actually felt cashmere before, and I would really like to. I tend to have pretty sensitive skin, so having a really soft shirt is my favorite thing. So one day I think I'll have to look into that. Okay, so looking at fiber classification, moving on to plant fibers. Plant fibers tend to be cellulose. So cellulose fibers are created by specialized plant cells. These are different from animal fibers because cellulose is a carbohydrate, not a protein, which means that it is going to have different chemical properties. It's also very resistant to chemical damage and is insoluble in water, which is helpful. So plant fibers will vary greatly. They might be thick, stiff, smooth, elastic, absorbent, or even amorphous, meaning they don't really have any distinct shape. So looking at a few different ways that we can gather some plant fibers, we'll start with seed fibers. For example, cotton is a seed fiber, and the cotton is found in the seed pod itself. A fruit fiber, for an example, would be coir. So that's made of the exterior of a coconut. So let me show you these images. This up here is cotton. This is the exterior of the coconut. You can see it's almost like a hair, but of course it's cellulose, so you can weave those together in order to make fabric, coir. There's stem fibers such as linen. Linen is made from flax stems, and you can see here these are all of the stems. It's being dried right now, and flax is unique because it's crystalline. So that creates a really dense, strong, long-lasting fiber. Linen is also really nice because it's cool and it's thin, so it's great for warmer climates. Leaf fibers are also pretty usable. So here is a picture of what's known as abaca. It's in the banana family. I don't know if you can see them, the leaves back here that kind of look like banana leaves. But manila is a fabric that's made from the leaves of abaca plants. So these are just a few examples, but there are so many different types of fabrics that you can make out of plant fibers. So let's look at the most common one, being cotton. Of course, we could go into all of the different ones as well, but you are welcome to explore those on YouTube. There are many a helpful video. So looking at the last form of natural fibers, we're going to look at mineral fibers. So these are neither protein nor cellulose. They come in a pretty wide variety. So there are a few examples that exist. Fiberglass, also known as wool glass, is really commonly used for insulation for buildings, so that's why I included this picture here. You can see that paint coming from the wall. Normally it's then covered with drywall, but this is made of really thin strands of glass, and this is a really good insulation, like I had said. And because the fibers are very fine, you want to avoid touching them because they can cause skin rashes. Essentially, you just get a bunch of little tiny splinters. So asbestos is similar in terms of its splintering tendencies. That's why you should stay away from large amounts of asbestos, and that's why it's kind of being strayed away from in terms of using in construction, because essentially it's a mineral that naturally occurs in different types of rocks, and it's really durable. It's a very useful natural fiber. It covers pipes, floor, ceiling tiles, fire-resistant clothing, but just like fiberglass, it has a tendency to splinter off, and those little splinters can get caught in your lungs, and they do more than just poke at your lungs. But I'm going to let this next video explain that for you. So just like I find it curious the way that we discovered silk, I also find the use of asbestos really interesting, and also as a cautionary tale of making sure that we stay up on the science and don't get too overconfident that we know what we're doing all the time, because that's where we run into issues. So going into synthetic or man-made fibers, these are essentially made by joining monomers together in order to form polymers, and these are all created in the lab. So we can kind of we can tailor these to whatever purpose that we want to tailor them towards. So there's quite a few different kinds of synthetic fibers. First, we're going to talk about regenerated fibers. So these are derived from cellulose and are mostly plant in origin. They've just gone through some chemical processing that changes the property of them for their desired purpose. So the most common is rayon. This is generally smooth and silky. Cellulose chemically combined with acetate will produce Celanese, which is commonly used in carpets. And when cellulose is combined with 3 acetate units, it forms a polyamide nylon, which is known as Capron. So I have pictures of these 3 different forms of fabrics here. I'm sure you've touched this before. This tends to be used in athletic wear more often, and then rayon, like I said, is pretty common. It's very smooth and silky. So this is an experiment that I'm hoping we'll be able to do in class, but being the fact that we're not set up for chemistry experience, we might not be able to. So we'll watch the video, and then maybe we'll get a chance to do it ourselves. I don't know about you guys, but I found that really satisfying to watch. So hopefully we'll be able to do that in class, but if not, may you have pleasant dreams of making rayon. So learning about another form of synthetic fibers, these are synthetic polymer fibers. So these are completely man-made versus the ones before, which were made from cellulose. These are instead made from petroleum or oil, and we can customize these even more for our specific purposes. Their properties depend on the formula, the shape of the spinneret, the dye that's used, pretty much everything that goes into the process of making the different fibers. So polyester is very, very common, and it's resistant to light and acid, so it's used in most clothes. I'm sure if you were to check the tag on your clothes, you would find polyester in there. Let's see. Do I have polyester in my... It doesn't tell me. I'll have to find a different tag somewhere else. But anyways, nylon is similar to polyester, but it's easily broken down by light and acid, so not as ideal. But then for some reason the only pictures I could find of nylon included ropes and ties, which doesn't make sense if it shouldn't be broken down by light. But acrylic has a light fluffy feel, but it tends to ball or pill really easily, so that's like when you have something in the dryer, it comes out and it has little balls of like fabric. That's something that you can do to like get rid of those balls. You can like shave them off, but still not necessarily ideal. So if you notice, the common theme here is that even though they can be customized for specific purposes, they tend to, I think, sometimes have side effects that make them not as ideal when compared to natural fibers. And then finally, olefins are used in performance clothing because they are really quick drying and resistant to wear and tear, so they're not going to like cause a hole from chafing or anything like that. So let's look at our final how it's made video, and this is really interesting. This goes into how people are able to take recycled water bottles and break them back down into that plastic, the petroleum, and then use that as the main ingredient to make polyester for clothing. Alrighty, so that is polyester. So going into a comparison of natural versus man-made, there are some key differences between the two. So synthetic fibers tend to be stronger than even the strongest natural fibers, which means that they're much less, they have much less tendency to break. But they're also not damaged by microorganisms. So if any bacteria or mold were going to try to get into them, they wouldn't be damaged by that like a natural fiber might be. But synthetic fibers are more likely to deteriorate in the sunlight, and they melt at lower temperatures than natural fibers. So there is kind of a cost-benefit analysis. So looking at the different fibers and some just basic characteristics, cotton tends to have more of a flat and hosed appearance underneath the microscope. It could be up to 2 inches long for one individual cotton fiber, and they taper to blunt points. They might have frayed roots visible under the microscope, and they might not always have a hollow core visible. Flaxseed tends to look kind of like a bamboo stick might, and it's straight with some angles, but it's not very curved. It has nodes, once again referencing that bamboo stick-like appearance, that are visible at as an X as every inch or so, and these often occur in bundles of several fibers. Remember, flax is for linen. Silk does not taper, but they do have small variations in diameter. They might be paired with raw silk or with another fiber, and they don't really have any internal structures. Wool will have surface scales visible because it is a hair. They're hollow or partially hollow in their core, and their fibers are up to about 3 inches long, and they taper to fine points. And then finally, synthetic, because they are once again made for the demand of whatever purpose we're trying to make them for. They vary pretty widely in terms of cross-sectional shape and diameter, and they generally tend to be straight with maybe some gentle curves. They are pretty uniform in diameter, and they might have surface treatments that appear as spots, stains, or pits, things that might be done chemically to continue to change that fabric for whatever purpose we intend it to be. So finally, we're going to look at different ways to assemble all of these different fibers. So yarn is very common. Fibers that are too short in their raw state can be spun together in order to make yarns, and then those yarns can be even twisted further. So short cotton fibers, for example, that are only about 2 centimeters long, can be twisted into a super strong, long yarn of any length, and rope is essentially just a really big piece of yarn. So one way that you can analyze yarn is based off of its direction of twist, as well as if it's from one single fiber, a mix of fibers, if it's natural, synthetic, a blend, etc. So using this information, you can identify the fibers that you'll find at a crime scene. So looking at the twist direction, you can see here there's a Z twist or an S twist, and if you look at the larger yarn, then you can see the individual fibers that are all spun around in order to make those larger strands of yarn. Well, I'm not sure why this one isn't loading, so we're gonna have to just look at it this way. So weaving has been in practice since the earliest human history, dating back as far as the Stone Age, and that's just in terms of like recorded history. But weaving consists of arranging threads side by side, which is known as the warp, and then crosswise going through, known as the weft. So this pattern is created based off of how the weft and the warp are interlaced. So as the weft passes over and under the warp, it'll create what's known as a weave pattern, and this can influence the style of fabric. So one thing I didn't know until learning about this before presenting it to you guys is that satin, as an example, is a type of weave pattern. It doesn't actually have to do with the type of fabric that's used. So looking at some of these different types of weaves, there's plain, which is just alternating warp and weft, and it tends to be firm, it wears well, it's snag resistant, it has low tear strength, and it tends to wrinkle. Basket weaving is alternating of 2 weft crossing 2 warps. This is more open or porous, and basket weaving is one of the earliest forms of weaving that we can find in history. It doesn't wrinkle, but it's also not very durable. It tends to distort as the yarns will shift through these gaps here, and it does shrink when it's washed. Now, satin is when one weft crosses over 3 or more warp threads. So if you can see here in this picture, there will be the warp threads and then like a big gap. So this isn't very durable. It tends to snag and break during wear, but it is very shiny, and it has high light reflectance and little friction with other garments. Twill is when the weft is woven under 3 or more warps, and then is woven over 3 or more warps and then under 1. So then the next row of the pattern is shifted over 1 to the left or 1 to the right by the warp thread. I wish I could visualize this. I don't have a very good mind when it comes to visualizing all of this information, but in terms of characteristics, the twill is very strong, it's dense and compact, it has different faces in terms of like the top and the bottom, they look different. There is a diagonal design on the surface due to the shifting over, and it's really soft and pliable. And then finally there's the lino. This uses 2 warp threads and a double weft thread. So the 2 adjacent warp threads cross over each other, and the weft travels between the right and is woven between the 2 warp threads here. So you can see it's almost like braided over the warps. So this is an open weave, and it's pretty easily distorted with wear and washing because of the fact that it's open, and it does stretch in one direction pretty easily, and I'm sure that it would be in the direction that's lengthwise, since that's how they can slide. So then finally, looking at then the weaving, we can see here these are the weft threads and these are the warp threads, and depending on the number of threads that are used in the weft and the warp, you'll add them up in order to determine the thread count. And the number of threads vary depending on the type of fabric that you use, the type of weave pattern that you use, as well as just what you want to use that pattern and that textile for. So when it comes down to looking at the thread count, normally a higher thread count corresponds with higher quality fabric. That's not always true, and there's a bunch of conversations on the internet depending on whether buying more expensive high thread count bed sheets are worth it, but I will leave that to you guys to investigate. Otherwise, this is the information that we are going to go through in different labs and activities over this unit of fibers. If you have any questions, I'd love to hear them. I also would like to find examples of all of these different fabrics and weave patterns to touch them in class, because it's one thing to learn about it, but I like to touch and feel to have that tactile experience. So maybe we'll do that. Otherwise, let me know if you guys have any questions, if you need any clarification. Otherwise, I will see you guys in class. Thank you.